Yeah, you will believe with me that it has actually been a journey from day one to day two to day three to day four. And today, which is a day five, is the last day for this cohort, which is our beginners focused data analytics training with Microsoft Excel. And I can see in the chat already, someone is already asking that how about data analytics using Power BI session? Yes, that's a very fantastic question. So data analytics with Microsoft Power BI will be starting next week, Monday, and it's also going to run for 5 days, just like we just did with the data analytics with Excel. Yeah, not to bore us with story, we'll have our awesome facilitator already on the call. I think Olamide Shogbamu deserves another round of applause in the chat room. Drop your favorite emoji if you no, if you believe that Olamide has been doing a wonderful job since Monday. Yes, drop your favorite emoji in the chat room. Drop your favorite emoji in the chat room. So I appreciate Olamide Shogbamu. Yes, thank you. Thank you, Shoremekun. Thank you, 30 Informatics. Thank you, HP. It has been a wonderful experience. In fact, sometimes I even wonder, is it still Microsoft Excel? Because the way it handles the whole learning, you will agree with me that it has been a very good one. Yeah, thank you so much everyone for joining again. Just few announcements before we start today. So, like I said, today is the day five, and we know some of you will be so eager already to share your learning experience with your family, with your colleagues, with your friends. So, we're going to be dropping the tags, I mean, the hashtags that you can use to make your post on social media. We're going to be dropping them before today's session rolls out, and also on the attendance. We've been taking attendance from day one, day two, day three, day four, and day five. Yes, so I think I also need to mention that the reason why we take attendance is because we are going to be issuing certificate of completion to everybody who participates in this program. And one of the requirements to be able to get your certificate is actually by participating. I mean, for those that actually pick the option to attend virtually, you will agree with me that we have three modes of learning delivery for this training. We have the physical, and some people are already on their way now to their learning centers. And then we have us here that are joining virtually, and we also have people that actually registered for the self-paced learning. So if you've registered to attend physically and virtually, that is why we create the attendance form for us to be able to get your details to know that you actually participated for that particular day. So the attendance is very important. Once the link drops, I encourage everybody to fill the form because we are going to be tracking the attendance from day one to we're already tracking already. So we're going to be taking notes of the attendance from day one to day five. So if there's a particular day you've missed, well, you can still fill the form because it means that you've actually been participating also. So you can still fill the form if you missed for the other days if you miss for the other days. But today is the last day, so I encourage everybody to fill the attendance form once the links drop. The other thing is that the Telegram group, which houses just a few number of the community members. I mean, we have over 11,000 people on that particular group, the Telegram group. It's actually one of our channel of engagement with our community members. So the link will also be dropping. If you are here to join the Telegram group, do well to join the Telegram so that you can all the community and what is happening at Data Science Nigeria. And yeah, so if there are any other information, we're going to be dropping it before we end the session today. And just to do a recap, just to mention it again, is to be that we actually make it in a gradual level. I mean, for people who are interested in becoming a data analyst, you can start with something as basic as this Microsoft Excel. And then from the third cohort, people who are also who wants to be a data scientist can start with machine learning with Python, and then they can move to machine learning with Azure where they get to do more of deployment. And then in the last cohort, we have the apps development that I only mark the attendance once. And I hope I'll get this out. So that's what I just made mention of. The attendance actually caters for each day. So it's very important that you actually fill for each day. It's very important that you actually fill for each day. Just one attendance for a day will not cover for all the attendance you missed. Yeah. So just to confirm again, I have Olamide Shobamo on the call. Yes, and is ready to take us on another learning experience of Microsoft Excel. And today, I think we are going to be learning statistics. Statistics in data analysis. This is another very interesting topic that you can actually learn on Microsoft Excel. Microsoft Excel is a very good service to do data analysis, and it's going to be taking on us introduction to statistical analysis using Microsoft Excel. Thank you so much, everyone. I wish us a great learning experience today. If there's any question that you have, you can quickly drop them in the chat. We'll have a lot of support team members on the call who will be attending to all questions. Thank you, and do enjoy the rest of the class. Over to you, Olamide.
Good morning, everybody. Thank you very much, Mr. Oluwabukumi, for that introduction and the preamble. I believe that the ground has been well set. The bar has been raised. It's now left for me to catch up with it. I welcome everybody to another interesting day of learning Microsoft Excel for data analysis. And this is the day 5 of AI in every city. And today is going to be the last day we'll be treating Microsoft Excel. So welcome everybody. It's a pleasure to be here, and I'm sure you guys are ready and happy to be here too. So like we do on usual basis, we just go straight to what we have for us today. So I believe you are ready. Please give me a minute to get my slide, and I'll be presenting now. So while I do that, you can invite your friends that you know they are supposed to be in this class. You can put a reminder on your group that you are using to mobilize your friends and your colleagues. You can just quickly do that so that they don't miss out of this very interesting part of this session. Okay, yes, I'm back. Let me know if you can see my screen, and you can hear me clearly. So today we are going to be looking at statistical analysis in Microsoft Excel, and to do this we are going to be using Excel add-ins. So I need confirmation from you if you can see my screen and you can hear me. You can see some people saying they can't hear me. Kindly please confirm if you can hear me now. Can you hear me now? Thank you very much, Grace. So I would continue. Thank you. Thank you, Rufus. Thank you, HP. Yeah, I'll continue straight to what we have, dive into what we have today. Statistical analysis and Excel add-ins. So by the end of today's session, you should have the practical understanding, and you should be able to use the statistical functions that Excel has. And by understanding, I mean know where you can find it, know what it can do, and know how you can use it. You should have confidence to like explore the different add-ins that Excel has on its own. Because Excel is so broad that keeping all the functions inside Excel itself is going to like be too heavy for the software. So there are some advanced functions that are called add-ins. And these add-ins are like you only get them when you need them. So if you don't need them, you don't really need to get them. So what are you going to be learning in this class? We will introduce you to statistical functions. In our previous sessions, we've talked about Excel functions, the basic ones, and there are some that are more advanced, and we call those statistical functions. We are going to apply them on our data. We are going to apply some of them on our data. We are going to do, okay, yeah, we also have here overview of add-ins for data analysis. We are going to look at the add-in as a broad concept, look at it from a bigger perspective. Then we deep dive into using it in a practical session. Then we are going to give room for question and answers from the very first day that we have started this class. If you have any question regarding anything that we have learned about, you can ask at the end of that. Okay, so let us proceed. So introduction to statistical functions. Excel is well known for its widespread versatility in statistical application. Excel function and tools can be used to execute statistical operations. This includes the basic ones that they teach us, no matter the parts of when we are in school, we do choose art, science, and then commercial. No matter the path that you choose or the department that you choose, we still get to learn about measures of central tendency, which are mean, median, mode. Yes, mean, median, mode, measure of central tendency. Then median is also part of it. Um, then we also have measure of dispersion. That is when we now learn about quantile, percentile, standard deviation, variance. So Excel, all these things are statistic, and Excel has a way that incorporates all these central tendency and central dispersion into it in the easiest form. Then it also has all these correlation correlation function like regression, time series, linear correlation itself, different type of distribution, Poisson distribution, binomial distribution. It also has all this polynomial. So Excel has all of these statistical function, and then Excel also have something that's Excel also have a way of testing null hypothesis. Yes, Excel has a way of testing null hypothesis, like doing the Z test, the Z test, the choice test, the so we are going to be looking at how Excel has implemented all these statistics into its software. So whenever we select the range of cell that allows a descriptive statistic, Excel presents us with statistical overview at the status bar of the interface. Okay, yeah, so I get what we are talking about here. And if you look at this picture that I have right here, you see that by the time I select a range of cells or a range of data, Excel gives me a quick statistical overview of what the data is talking about. I can quickly see the average, I can see the count of the entire data that I have selected. I can see the sum of it. So yeah, this is like a statistical brief. Like, oh, I don't need to write a formula for average before I know the average of what I have selected. I can just select it, and Excel, it prepares a statistical summary and just do an overview presentation at the status bar right here. Let me use my laser to point it so that everybody can see it. Yes, right here, Excel just does a statistical summary and present it at the status bar. So if I want to see the average of, let's say this column right here is mathematics. If I want to see the average of all the scores in mathematics, I can just highlight just this column. Excel will do average, count, and sum for me. And yes, I can actually edit these functions here. I can select the one I want to see and the one I don't want to see. If the one I am conversant with, I am always asking of, or the one I always need is something like, say, maximum, or the one I always need is trying to, okay, count is always needed. I'm trying to also see something that is important when we are doing some measure of central tendency. So basically, okay, let's say we need maximum. Let's say we want to do the range. Then we need maximum and minimum. I can just edit these functions and include maximum and minimum here. So that maybe I want to do let's say class boundary, or I want to do something like just range, ordinary range. I can actually see the minimum and the maximum, and then I can do a quick calculation without having to input any functions that is complex, or that is I have to type a code to open bracket and all. By just highlighting and selecting the range of the data, I can see a quick statistical preview, and we can always take note that these here are editable to prioritize the function that we want to see very, very quickly. So let us continue um, with what we have today. So we have seen that Excel can do some measures of central tendency and measures of dispersion. So here I have just list some of the statistical functions, how we use them, and what they do, because that is the whole concept of understanding. When you know how you can use something and what a particular function can do, then you have the understanding of that function. Then when you are challenged with a problem or you are confronted with a question, you can now use the understanding that you have to solve it, because I know that median can do this, and then this is how I can use it. Then you are going to be able to apply median when you are confronted with a problem on median. So it no longer become a big word, or it no longer become something that is strange, because you already know what it can do and how you can use it. So let us do a quick rundown of some of the functions that I have listed here and understand how we can use them. So here is one thing that we need to know also, that Excel has over 100 statistical functions, like it has over 100. The other time I was introducing us to function in Excel, where we use the function tab and I say insert function. I remember mentioning that you can actually search for whatever function comes to your mind, and then you can see if Excel has it or Excel does not. Then if Excel does not, if you can write your function in a logical way, let's say in a mathematical way, you can write it out in an expression, or you can write it out in an equation. Then you can actually save it in Excel and give it a name. You can actually call it your name. Maybe you are into like a community contribution and there's a particular way you people calculate your interest, and that particular way is a formula that you have derived by yourself. Let's say based on the number of people that are contributing, you have derived the formula by yourself, and you have actually classed it that these people are the ones that are rich, so they are collecting more money. These ones are the ones that are in the middle range. Yeah, so if you write your formula by yourself, you can just save it and save it with the name of your community or with the name of your contribution or with any abbreviation. And whenever you type equal to the name that you have saved, it actually activates your function for you. So let us quickly not waste too much time. Let us look at mean. So yeah, mean is just like average. It calculates the arithmetic mean of an argument. So in this case, just type equal to average and specify the range where you want to calculate the mean. This another one is median. Median finds the middle value in a set of numbers. It also take into consideration the order of arrangement. If you are arranging in ascending order or descending order, we remember that critical this is a critical condition when, or let's say it's a critical step when calculating median. The reason why I'm always saying this is that when I was still learning um mathematics, then not really mathematics, just basic mean median mode, all this, yes, mathematics maybe from senior secondary school one or JSS3. Then anytime we are doing median, I don't sort my data. I will just do median. I'll add everything divided, then split it in the middle. So I always get it wrong, like every time. The funny thing is that you are going to be very close to the answer. So if the median is 9, you can actually get 8 as the median. Or if the median is even and you are dividing it by 2, you will still get something close, but you will not get the exact close thing. And you know this thing when you write the test and then you don't know why you are wrong. Yeah, because I believe it is the same way. We take the data in the middle. If we have even number, we take the number in the middle. If you have odd number, you take the number in the middle. If you have even number, you add the number together and divide it by 2. So I always, this thing is, median is not hard. It's not even as hard as mode or mean or any other thing. I'll get the remaining, but then it's median I don't always get until I realize that you have to sort your data, arrange it in ascending order and descending order. So it's like whenever I'm telling people about media, and I always emphasize my mistakes so that they don't make the same mistake I used to make. So even when you are using Excel, you don't have to like start sorting. Excel will already sort for you. So another one is mode. Mode is like the highest occurring frequency in a data set. So there are two different cases in mode. So these are some of the questions that will come to mind when you have a real life data set. So you are going to face some of these challenges. So when you know how to handle it, it is good. We have single mode and we have multiple mode. So when you type equal to mode, and you specify .sngl. When you even type S, it will automatically complete it for you because S is single, meaning that you want to pick the first appearing highest frequency number. So if I have a frequency table and I'm trying to okay, I have a frequency table, I'm trying to do mode. And I have two numbers that are appearing, let's say the highest occurrence is 5. Then I have two different data points that are appearing 5 times. I can select a single one, means that I'll select the first one that is appearing 5 times. Then I can select multiple mode by using multi. That is mode.multiple. I'll just specify the range and then it will select both data points for me. Yes, that is what stat does. Then we also have standard deviation. All of these that I have mentioned, they are measure of central tendency and measure of dispersion. We have not gone um into the statistics, into the major, or let's say into the advanced statistics. These ones are just basic measurements, and basic measurements they are also used in economics matter, so they are also statistics. In fact, they are also statistics. Standard deviation is also in two ways. We have standard deviation for the population data. We also have standard deviation for the sample data. So for this class, everything we are going to be doing is going to be sample. Sample, yes. So sample standard deviation dot s is it you are simply saying standard deviation for sample data. So there's a way it estimates that if you're a statistician or if you have gone into statistics, you realize that there's a way we specify population and there's a way we specify sample in order to cover up for the population that we have not captured. So the difference between population and sample is that population is the entirety of that data. So if I am in a class, let's say in a classroom of 60, let's say 20 people, I'm in a classroom of 20 people, and I want to test the intelligence of all the students, I can do it in two ways. I can go to the class teacher and take permission and start calling all of the students one by one and start asking them questions. That one, I am testing the entire population. Or maybe because it's going to take the whole day and the students don't have the whole day to spend in school, I can just tell the teacher, I'm going to be picking at random. I want to pick three students. Let's say I want to pick four students, two boys, two girls. And then these two boys, two girls will be representing your class. What I just did is sampling. I am taking a portion of that entire data and then I am making my hypothesis for the entire population on that sample. Let's say I'm making my conclusion for the entire population on those two samples. So the same way when we do this teaching practice, and then they tell your supervisor is coming, you arrange the students that are bright, the ones that are good, you arrange them in front of the class. So that if the supervisor want to call anybody, they will call the ones that are bright and tell them yeah, the one that should answer. So you are trying to make sure that they pick the good samples and they don't pick the bad samples. So because it's just a technique. So in statistics, there is a way we account for sample and there is a way we account for the entire population. And that is why we have to specify dot S and then dot P. So the same thing goes for variance. So when you type in equal to VAR, then Excel understand you are trying to do variance. And then if you put dot S, it means that you are specifying for the sample. So what is deviation and what is variance? Deviation is the amount of spread or space a data point used to deviate, used to go astray from the average. Like the other day, I was explaining whisker and box plot. I told you that there are some outliers that leave the community maybe by going upper or going below it. So it means that those ones that deviate from the average, from the common people, and those ones are the ones that are going to have high deviation. So if we want to know the distance by which they have deviated, that is when we now look at the variance. So that is how standard deviation and variance is. So normally when we are calculating distance, we take the square root of a distribution. That's how we do distance. So when we're also looking for variance, we take the square root of a standard deviation. So count all, normally for every statistical process, we have to give account for the number of sample that we are using. And that is where count all comes in. If we look at it very well, or if you remember very well, there is hardly any statistical formula that you know that does not have n inside it. For mean, we have x over n, summation fx over summation x. Yes, over n rather. Yes, over n. Summation fx over n. That is the formula for arithmetic mean. Then if you are doing there's this other mean whereby we use assumed mean. That is when we do x bar minus x all over summation and stuff like that. Everything has n inside it. Even if you are doing standard deviation, the absolute of x bar minus x all over summation is fn. N is always there. And that n in this case is the count all, because even when we are doing addition of all the statistical functions, when we are doing their computation, we even take into account the mistakes that were made, we take into account the values that are not existing, because at some point for the data to appear, it means that the data is represented. Yeah, that's what I'm trying to say. if the data is if the data is present, it means the data is represented. Let me say, for instance, I'm trying to sample people in a class and I'm trying to sample 20 of them, and I pick two boys, two girls, and I'm asking them oral question, and they are giving me answer which I'm typing out. And then it gets to my fourth sample point, and the boy cannot speak. Maybe he's dumb. Now, that boy did not say anything. His entry is going to be empty because he's dumb. But because the boy is in that class, it means that the boy is represented in that data. So I cannot say because the boy is not speak, I'm removing him from my sample. No, he's going to be part of my count. And that is why we are using count all, because count all accounts for every point in the data. So we do not use ordinary counts, we use count all. So these are some of the functions that we usually use when we do statistics. And we are going to be seeing them like in a short while when we proceed to the hands-on. So let us look at more functions that we have. Yeah, so we also have the quartile, we have percentile, so quartile is basically dividing a data into quarters, into four. But now it's dividing it based on their rank. So it is based on their distribution. So it's not just dividing it into equal parts. No, because if it's dividing it based on position, or let's say based on equal parts, then there's going to be a bias in the data, but it's actually dividing it based on their distribution. So that is what quantile does, and the formula is quantile. The INC that is there is standing for inclusiveness. So I'm looking for a way to define inclusiveness in I'm looking for a way to define inclusiveness in a data set. There's one very common operation that we do whereby we say inclusive or not inclusive. Okay, yeah, I think I know it now. It might be a little bit complex for us based on the fact that we are just learning. But in set theory, when we are doing set difference, we will say inclusive or not inclusive, meaning that are we adding the boundary or I don't know how to make it more simple, but there is a way we say, I have divided this data now. Let's say I have 8 points and I have divided it into four. It means I have 1, 2, 3, 4, 5, 6, 7, 8. Now, when I say 1, 2, 3, 4, you remember that I am dividing it on 2 and 3. It means that 2.5, if it's a real life division, 2.5 is being shared by 2. 2.5 is also being shared by 3, meaning that 2.5 is the two of them that owns it. So when I say inclusive, I'm going to include 2.5. When I, yeah, when I say inclusive, I will include 2.5. When I don't specify inclusive, I will not include 2.5. So that is what that just means. So that is a little bit deviating. We are not trying to deviate. So let's come back to our focus so that I don't lost us. We also have percentile. Also in this percentile, we can define inclusiveness and we can decide not to define inclusiveness. But unlike quartile, percentile divides the data into 10. So we can specify the position that we want to return. So if you look at this quartile, I said quartile INC, my range is B2 to B12, then I said comma 2. This comma 2 right here is saying I want to get the second quartile. So if I say comma 4, I'm simply saying I want to get the fourth quartile. I can specify the quartile that I want. When I come to percentage, I am simply saying, okay, percentile, I want to get the 60th percentile, and that's what I did here, 0.60. I can say I want to get the 30th percentile, and that is, I'm just going to specify 0.30. So this percentile is always common. It's a common question to ask based on you want to know which distribution of the data is actually doing the work, and that is where that comes in. So we also have min and max. I've explained this earlier that is they are useful when we are looking for range in a data set. They are useful when we are looking for range in a data set, or when we want to normalize a data set. Yes, we can actually use min and max and we specify them by saying minimum and maximum. So when min and max is able to help us get the highest number in a data and the minimum is getting the lowest number in a data set. So what if I want to get the second to the first five highest number? Let's say I just want to preview them. So this is where small and large comes in. So small and large allow us to get like the first nth value, whether highest or lowest, and then it allows us to print it. So for the lowest value, we use the small. For the biggest value, we use the large. So to specify the position where you want to get, you say equal to small into brackets B2 column to the range where you are going and specify the number you want to get. So if I want to get the third position to the highest number, I specify 3, meaning that it's going to count the highest, second highest, and third highest. Then it will print the third highest for me. Then if I want to get like the third lowest, I also specify that using my small keyword argument. So we have correlation. Correlation quantifies the linear relationship between two data sets, returning a number between -1 and 0. So -1 simply is signifying that this is not correlating at all. Then 1 is simplifying that it is perfectly aligning. So any number that is above 0 is positive, telling us that there is a chance of correlation between these two data points. And how do we specify correlation? It means that we have two arrays. I'm looking at correlation between this list and this list. So if I have students that write English and I have their scores, and I have students that write mathematics, I have their scores, I can actually check their performance and see if it is correlating. Or I have students that actually know math and then they don't know anything about English, then I'm not going to have a correlation. It is going to be a minus. So we can actually use the correlation function, and it is a very good function to use when we are doing a statistical presentation or we are trying to prepare a statistical analysis. Because by the time you take observation from different people, and then you want to see how is this thing affecting this particular thing. Let's say I'm doing a survey and I have taken people's opinion the price of fuel, and I've also taken people's opinion about um fuel usage. I've asked them price of fuel, how their opinion about it. I've also asked them how much do they use fuel. So I want to see if there's a correlation between how they use fuel and the price of fuel. So I can actually use a correlation for that kind of analysis. I would, after preparing a table, after preparing, let's say, some indicators, I can still use my correlation function to make a card and show a correlation. and still use a linear graph or a scatter plot, or I plot the two together, I can still use those two things to still show the correlation and make my report more robust. So we also have a distribution. So this calculates the probability of a value falling between a normal distribution. So normal distribution is a distribution that falls between the average. Yes. So we all have it's always like this bell-shaped curve. It's always like a bell-shaped curve. And then the edges of that bell-shaped curve are the ones that we take as our dispersion range or our variance range. Means I don't know how to explain this more further without a picture. But then it help us distribution with specified mean and standard deviation. So we specify the mean, which is going to be the average, and then we specify the limit for the deviation. So we see how the data is distributed. Is it within the specified standard deviation? So it enables us for analysis of data patterns. So to use that, we say normal dot distribution, then we specify our range. We also specify our mean, meaning that this is the average of this data. Then we specify our standard deviation. This is the extent that you can go. So if we plot it and there are some points that fall outside that standard deviation, it means that our data is not normally distributed. And then we can also have, let's say, a distribution that is skewed to the right, a distribution that is skewed to the left. So we have those kind of views that we can get from the normal basic statistical function in Excel. So let's continue. We have the Excel add-ins for data analysis. So like I mentioned before, there are more functions because there is over 100 functions actually. Apart from the loads of functions that we see under the function tab, Excel also has like a library that is ready for you to connect. Best use because we don't use it all the time, so it is better that that library stays somewhere that is not inside Excel, and whenever we need it, we can always activate it. And that library is what we call Excel add-ins. And we are going to be looking at how we can use these add-ins in Excel in a short while. But let us quickly run through a step-by-step guide on how we can implement this add-in into Excel. And yes, we can move straight to our practical session. So basically, this is a step-by-step guide to using add-in for data analytics. Apart from the functions, we also have several Excel tools for statistics. We will discuss two most important Excel tools for quick statistics. I've mentioned one before, and okay, yes, we can still look at two. We can still look at two, but we are going to be looking at one, which is the one I have specified here. And by that, I mean the analysis tool pack. So to use this tool, we need to configure it first. So how do we configure it? There are two ways we can do it. I'll be showing us the two ways, but the step-by-step approach is first you go to files. Remember, there are different tabs on the Excel ribbon. We have file, we have home, we have insert, we have layout, we have preview, we have review, we have view, we have tabs like up to 9 or 7 of them. And then when you click files, you see at the bottom, okay, if we are all looking at the screen now, it's going to be our left side bottom of the screen. We are looking at the screen. So it's going to be at our left side at the bottom of the screen. So you are going to see option. So if you click on those options, it will bring out more options for you. And under that, you see add-ins. So under the add-in function, if you click it, you are going to see by default, you are going to see Excel add-in. So we are going to look at this thing so you can see how to activate it if you have not already activated it. So if Excel add-in is being selected, you click go, a new pop-up dialog, a new pop-up will show like this, a dialog box like this, allowing you to interact. So like this one that is here, this is Excel add-ins, and then you can see that I've checked this analysis 2 pack. So there are a lot of add-in. There are more that you can browse. If what you are looking for is not here, you can actually browse more. So if you are browsing more, some of them are paid, some of them are not paid. But the ones that are here, this analysis 2 pack and this analysis 2 pack visual basis for application. Then we also have this euro currency too. These ones are not paid. But if you are browsing more, you can end up coming in contact with the ones that are paid. Oh, sorry about that. So we are going to be focusing on this analysis 2 pack in today's class. So if you click on it, then you can go to your data. In the data tab, a new group named analysis will appear. Okay, yes. Click on data analysis to see the list of statistical tools that are available. So when you click this and you check it to activate it, in the toolbar, in the ribbon, under the insert tab or data tab, under the data tab, data analysis tool, the icon for you to click and select different statistical analysis will appear. So when you click on that, we can then start using the different statistical functions that we have in Microsoft Excel. Okay, let us continue. All right, so this is going to be the data sets that we are going to be using for this class. The same data sets that we used yesterday. If you have it downloaded and you are loading it in the same way that we have been loading data, it means that you don't have to download it again, meaning that your data is still intact. The same way it was yesterday is the same way it is going to be now, and then just load it into Excel again. So while you get your data set ready, I'd like to take a minute to quickly drink water. I'll be back in a minute, and then when I come back, we are going straight to Excel. So just use this opportunity to get your Excel ready, and if you can load your data set in Excel, and I'll be taking a minute now. Okay, so I'll be back. Okay, so let's get our data and let's get to Excel. So we can this. So I'll stop sharing my screen now and I'll share my Excel screen. I'll see my screen now. Okay. All right, so let us load our data into Excel. So come to data, we get data. So because I downloaded this data yesterday, I will not be downloading it again. Okay, let's just download it for the sake of people that did not join us yesterday. So to download this data, that means I have to stop sharing and share again. So the link to the data set is what I'll be dropping on the group now. So if you click it, so that is the link to the data set in the chat session. So if you click this link, it will open. Show us how we can download the data. I'm trying to spin up my browser. Let me just share my browser so that we can all see that. This data, the link is bit.ly/AI_ed_t4. So with this, you can get the data. So it's if you click the link, it will open something like this for us. So once it's something like this is opened, you can click on file. That's me, I'm right here on file. So if you're on file, you can click on Excel because there are two sheets here basically. Click on download and then download Microsoft Excel. So if you click this download Microsoft Excel, your data will be downloaded as you can see it. Yeah, Excel everyday default. So that has been downloaded. So I'll go back to my Excel and we can continue from there. So we get data from file, from workbook, and data that I just downloaded is, I think I know where it is. So here, AI everyday default. So if I import it, I have two sheets in the data set, so I'll be loading the two sheets separately. But most importantly, the one that I need now is statistical, lookup. So I'll do the lookup. I don't need this. Close it. Then my data is here. Okay, now let's quickly go into statistics. So I want to show us how we can get the add Excel add-in. So there are two basic ways you can do that. So the first way is to come to this search bar. I believe you can see my screen. I believe you can see my screen. So the first way to get the data is come to this search bar and type add ADD for addition. Add, then ins. So if you type add-ins, you see this first one, that this best action right here. This best action, if you click on it, you spin up this dialog box, and this dialog box is the one that we have seen in my slide. So remember what I told you this search bar does? It search anything in Excel, even if that particular thing you are searching is outside your workbook, it can search for you. So it search virtually anything in Excel. As long as it's on your system, it's in your documents file manager, it can search it. So we search for that, and you can see this one is automatically checked. So if it is not checked for you, just check it. So if I uncheck it now, let me uncheck it and click OK, so that I can use the other method to check it later. Right. Okay, so we click on OK, and now I have unchecked it. So we can see some things have changed in my interface. So if I come to data here, you see in this particular tab right here, this place that my mouse is hovering at the edge of my screen, there is nothing there. And this is where the analysis tool is supposed to be. So let's use the second method to get it back. So if you have used that method to get it, you are fine. So I want to use the second method to get it back. I'll come to File, and under File, look at Option. At the bottom here, I'll click on this option. And if I have that selected, I will look for add-ins. So we see general, but we see add-in here. We see add-in here. So if you click on add-in, trying to manage my time because there's something else I want to show us after this analysis statistics. So if you click on this add-in, under this manage, you see that Excel add-ins is selected by default. There's a lot of add-ins here. All the ones that you have activated are actually here, and the ones that you can get. These ones are the inactive. These ones are the ones that you can get that are inactive. And these ones are the ones that you already have that are active. So Power Map for Excel. This one I got it on the day we're doing visualization. When we wanted to visualize a map, that was when I activated this. But these are the remaining ones that you can actually get for free. So right now, Excel add-in is selected. So I'm going to click on Go. So you see that this now is nothing is checked. So I'm going to check this analysis two pack. So I'll check this analysis two pack. So once I click this analysis two pack, I click on OK. So it gets it for me. So we can see this again, that under data analysis is now here. So this is the one that we normally use for our analysis. So before we go there, but before we go there, I want our reactions and our contribution in this lesson. So if you can help us with the common measure of dispersion and measure of central tendency that we can measure for a summary statistics. Because what I want to do now is that I want to do a summary statistics of this report, So one thing I want to do first is, okay, let's continue. So let's quickly do a summary statistics of this report. So so to do a summary statistics of these reports, we can use the manual method and we can use the Excel add-in method. Okay, because of time, let's just use this data analysis. So if you have this data analysis here now, let's come to data tab, data analysis. So I'm seeing some comments, and somebody says I should take the add-in method, the add-in process. Somebody said, how did I get automate to the menu bar? Okay, that is actually another integration into Excel, which is not part of this class. But that's like Power Automate, and it's a different topic entirely. So the adding process isn't entirely clear, yes. So I'll be taking that again. So there are two ways of doing it, and I'm going to be taking the two ways again. So let's just look at that together. The first one is you can come to this search bar. If you have your Excel open, at the very top part of it, this search column, this search box, just inside the search box, type in adding. Add for addition. Space. If you want to put space, put space. IN for in. Because there are multiple kind of things you can get inside. So we have add ins. So if you want to put space, put space. If you want to put hyphen, put hyphen. Both works. So if you press enter, the drop down, you see best action, or even the first one that you see in action. But I'm clicking the one that has first action. It says manage the add-in available for use with this file. So I'll click on the first one. So somebody said add-in is not showing. So when you click on that search bar, add-in is not showing. So if that is not showing, let's go to the second method. So if you click on file, I can go back, look at these different tabs: home, insert, layout, formula, data, everything. So the file, the first one, click on it. You might need an internet connection to get it actually, but I'm not so very sure of that, but I think you might need an internet connection to get it. So click option, if you click option, that is the last option to the left, the one that's at the bottom corner. You click option. This pop-up will come up. I believe you can see this pop-up. Yeah, I believe you can see the pop-up. So once it pop up, you see adding here. Second to the last one here, adding. And then if you click on that, by default, Excel adding is being selected. So under manage, Excel adding is being selected. There are others that you can actually select, but we are using Excel adding. So if you click on go, these are the options. So it brings us back to add-ins, and then make sure that this analysis to packed is checked. Make sure that the analysis to packed is checked. Make sure that the analysis to packed is checked. So if you click on OK, then you should be good to go. So if you have done that, you should be able to get to where we are. So now let us explore the different functions, the different statistical functions that we have in Excel. Just come to data here and click on data analysis. So once you click on data analysis, you are going to be introduced to another world of possibilities with Excel. A whole lot of possible things that without the adding, you will not be able to, you will be able to do it, but you might find it as a long process. Because at the end of the day, by the time you start creating your own formulas and inputting it together, you have like 10 different sheets doing one function. But with the use of this data analysis tool now, with just one click, you can do a whole lot of things. So here are some pre that are here already. So the first one, ANOVA is analysis of variance. One-way ANOVA is a single factor ANOVA. Two-way ANOVA is a two-factor ANOVA. There's one with replication, there's one without replication. So it's just like saying inclusive and not inclusive. So we have correlation, we have covariance, we have descriptive statistics, and this is the first one that we are going to do. Just do a descriptive statistics of all the numbers that we have here. So you have exponential smoothing. We also have Fourier analysis. So this Fourier analysis is actually a useful analysis for people that know how to use it. We have F-test, which is like so we have F-test for two sample of variance. I want to remember what that F-test does. So I think it's like a fit test or something like that. So we have histogram. So this histogram actually does a frequency table and it draws the histogram for us. So this one is different from the normal column chart that we have. This one actually takes into consideration the class interval and the bin number, the bin size. So we can actually look at this too. Takes into consideration the class interval, but before we use this, we have to define a class interval. And our data does not have class interval, but it's something that we can handle if time permits us. So we have moving average. So if you are into like all these cumulative and continuous data type, so you understand moving average. We have random number generation. This actually can generate random numbers and you can use them for practice or just for random projects. We have rank and percentile. So this one does another, this is something cool we can actually look at. We have regression, we have sampling. One of the things I'm interested in, we have the t-test. T-test in a two-way sample. We have z-test also. We have two samples assuming unequal variance. We also have two samples assuming equal variance. So these are different tests we can actually do with this data analysis too. So let's start with descriptive statistics. Descriptive statistics. So let's click on that. Let's click on that. Let's click on descriptive statistics. So if you click on it and you click OK, a new window will come up telling you how do you want to do this. So I'll be selecting the numbers. So for this data analysis, well, some of them are actually some of them actually take column headings, while some of them don't take column headings. Just give me a minute. I want to quickly look at this. The message just came in and I think I need to look at it right now. Just a minute, please. So we can continue. Oh, sorry about that. Yeah, so we can continue actually. So input range. So I'm trying to explain this input range before we got interrupted. Some input range will take column heading and some will not take column heading because it is not a number. So it is best practice, not even best practice. Let's say it is my practice because I don't know what other people use and I've not like compared this with what other people use. But it is my practice that I don't put column heading, I just put the numbers. So I just put the numbers and I want a summary statistics of this. So I say group by column. So group by column now means that I'm doing the summary of people that did mathematics, people that did English. So my summary is going to be For maths, English, biology, chemistry, and physics, yes, group by column. So I want my summary to be in a new sheet. Then what else do I need? Label in the first row. Okay. So this will allow me to actually add my label. So let me try it. Okay, let me try this first. If I click OK, please choose at least one statistical option. Okay, I've not done that. Summary statistic, yes. Confidence level. I think that should work now. So this does like a summary statistics for me. So let's go back and make it better because I've just seen a way to make it better. So I'm going to be doing this here again. Okay. So let's go back and do this again. So I want to include the column name now so that it can be clearer. So click on descriptive statistic, click on OK. So just include the column names and click OK. So I did this, I will select this. So I can do this. Okay, now we see it is clearer now. So we have mathematics and then we have a summary statistics of all the scores in mathematics. Then we have English and we have all this summary of all the scores in English. Then we have biology, we have summary of all the scores in biology. So and like that, we have this. So if we're to write formulas for all of this now, it will take us like over 1 hour. So basically how I input the column is by clicking and dragging. It's self-referencing. It's by clicking and dragging on the column I want to use. So I just click and I drag through everything. So what I'm actually saying now is this. I can actually look at the range of my score for mathematics. Okay, I think I'm on this sheet. Yes, I can actually look at my range for score in mathematics. I can look at the range of score in English. So it means that the range in this English is much, meaning that there's somebody that scored 100 and there's somebody that scored 1. Look at minimum and maximum. So the range is much. The same thing for almost all the subjects. While I have people that scored up to 99, I have somebody that scored 1. While I have somebody that scored 100, I have somebody that scored 3. So if the range is much, it's telling me that there are some people that are far behind in the class. So I can come and look at the average. So what is the average of the class if there are people that are far behind? One thing is that one of the statistical perspective that you are supposed to have is that once the range is much and you know the highest person in the class. Let's take this mathematics for instance. Let me zoom in on this. How you can actually draw conclusions from summary statistics. Um, let's take this mathematics for instance now. I've seen that my range is much. 87 is a wide gap for a score from people that have 1 to 100. It means that there's somebody that scored like minimum 13 and then there's somebody that scored 100. So is it that what could be wrong? Or is it that this person that scored 100 is a genius? Maybe he's the only genius in the class. Or maybe he's an exceptional kid. So I can actually clear that thought by going to the average. So if I come to the average and I see that the average is actually less than 50, then I will know that this person that scored 100 is actually exceptional in the class. But if the average is close to 100, then I know that this person that scored 13 is doing below the class. So that is one way you can actually use summary statistics to, to get that. So now this average is close to 100. It means that more people in the class actually did better, but this person that scored 13 did below most of those people. And that is what that does. So I've chose my confidence level to be 95%, and that is where my standard error is. I'm able to get my standard error from. So this standard error is actually less than 5%, meaning that it is acceptable. So if the standard error is above 5%, then you need to check the data or you need to check the process. So that is so somebody said they cannot select the data at once. So let me give you a shortcut. Click on the very first cell and press Ctrl plus Shift and down. So if you click on the first cell and you press Ctrl, Shift and down together, you are going to select the whole of your data like that. So I'm still explaining descriptive statistics. So we have the median of the class. You can see that the median still falls around 89. So if the median falls around 89, and remember that we have sort our data, so it means that this particular person, this particular class, most of them actually did better. Most of them did better. And another way to confirm that most of them did better is that see the mode. The mode is actually 97, meaning that most people in the class scored 97 for mathematics. Most people in the class scored 97. So you can actually do it across all of the subjects and say, okay, English, biology, and the likes. So we can see deviation and we can also see variance. Variance is the square root of deviation. It's only help us to highlight how things are deviated. So if we look at the standard deviation, so we can see a standard deviation of 22.000. So meaning that the highest deviation that somebody has is by something like 22. Now, this is easier to interpret because this data is actually ranging from 1 to 100. So if it were to be a data that is ranging from, say, 0 to 2500, then there is going to be a need of conversion into like a percentage style for you to be able to say that this particular thing has deviated by 20%. But because this data ranges from 1 to 100, that's why I'm able to say that the standard deviation is the data is changing by 22 units. So it means that for the person that scored 13, maybe the person that scored above him scored something like 25. And then the person that scored above later scored something like 37, 36. So the average distance of deviating is 22, which is high. It is high, and then we can say that this is why there is a big range between them. So we also have the skewness. The distribution is a little bit skewed to the left. That is why we have, it's a little bit skewed to the right. That is why we have -1. So if you also look at the data again, a visual imagination of the data. If a data is skewed to the right, meaning that more people, more data points are in the right position. So it means that more people actually scored around 80 something because the data is skewed to the right. If the skewness is 0, it means that the distribution is uniform. That is when you can say everybody score like 50, everybody score 100, everybody score 90. That is only when you can have a skewness of 0, and that is when the data is uniform. So these things I've been explaining is a little bit of statistics, but we are looking at statistical analysis in Excel. So I think it is important that we talk about them. So I'm just using the simple one that some of us are familiar with, which is the descriptive statistics, and that is what I'm using. So so we can actually see for all the subjects, and then we can look at the minimum, the maximum, the tortoise. Tortoise is very similar to skewness, and we've seen range, we've seen sum, and then we've seen count. So basically, that is what descriptive statistic is. Let's look at another statistic, another analysis that we can do. I doubt we'll be able to do dashboarding. I was thinking we can do a little bit of dashboarding to wrap up the Excel class, so that if you want to do a project and you want to share on social media or probably you want to share as your own project, we are able to do a dashboard and you can showcase it, or the program facilitators can actually request it for, for evaluation, because it's actually going to be a good thing if we can do it, but we have approximately 40 minutes, which in my head, I take as 30 minutes. So let us look at analysis of variance. And the reason why I'm choosing analysis of variance is that we have 5 subjects: physics, mathematics, chemistry, biology, physics, chemistry. So we want to do analysis of variance. How is this thing varying? Or let's do average and let's narrow it down. Let's do average. So yeah, I'm going to be using average function. If I want to use average, average of all of these guys. So with this average now, so I can actually check the variation between mathematics and this and their average score. Some students can actually do better in one subject and their average will be low, maybe because they did it worse in another subject. Or some students can actually have low score in a particular subject like English, and then they would do better in their overall average. This happens to most people. Maybe you have Yoruba in your subject combination, and then you perform a little below par in the Yoruba language, but your average is still good. You will not be bothered. So those kind of things, analysis of variance, we can actually use analysis of variance to understand them. So we are going to be looking at 2 things now. There are different types of ANOVA. We have two-way ANOVA and we have one-way ANOVA. So we are going to be looking at the two of them. So welcome to statistics class. Let me use this. Let me use this. Let me delete this. And let's quickly do, well, there's one reason why I like ANOVA. It's because when they were teaching me then, I was not serious. So when I wanted to write the exam, the whole note for analysis of variances, the whole course, in fact, you do it 2 times in the university. So you do it 200 level, and then you do it, I think you do it first semester and over one, do it another semester and over two. So you take a whole session to teach you analysis of variance so that you see how useful it is, and for statisticians they don't play with it. So me myself, I was playing with it, saying read it when the time comes. So I read this course a day before the exam, so I read the old notes. So that is why I like analysis of variance, because it challenged me to sorry, I want to clear format, because it's actually put a lot of effort into it. And yeah, so we go to our data. Let's select data. Let's select data analysis. Let's select analysis of variance. So let's do a single factor analysis of variance. That's just going to treat a single column. So I mean, that's not interesting enough. Let's do two-factor with replication. That's a two-way ANOVA. So if you click OK, so it tells us to select our data range. So if you select data range, no, let me go back. Let's do one-way ANOVA before we do two-way ANOVA. So we do a single factor ANOVA, and then we select our data range. Let's select the subjects. So I'm selecting all of the subjects and the average. So I'm including the average. So I'm doing 6. So I'm grouping by column so that we can actually do one easy comparison between mathematics and average, English and average, biology and average, physics and average, chemistry and average. So group by column. So the alpha is 0.05. Alpha is like a confidence interval. Yeah, confidence interval. We have, is it interval now? Yeah, interval. We have confidence level and we have confidence interval. So at this point, I'm telling them that my confidence interval should be greater than 0.5, meaning that I don't want to tolerate mistake that are greater than 0.05. So that is what this does. So I want to also include my label. So I want to use a worksheet. So let me just use this one here. So I'll just use that one there. So sheet 2. So it's telling me that my worksheet range is not valid. So sheet 2 and then I'll click it here. So if I do this. Why? Okay, let's do that again. Now, this is why specifying a new sheet can be easier sometimes. Okay, this is our results. Please, I want to do this again. So this single factor. Uh, okay, this is two-way ANOVA. I will explain this to us. I know it might look strange to some of us, but fine. I'm looking for, okay, yes, this is it. I'm actually looking for this. Supposed to write it as the name of the subject. So I want to delete it and do it again. Sorry for that. So that it will be easier for me to explain and it will also be easier for you to understand. So let's do that again. I hope you can see my screen. So let's delete this. But let me delete your sheet. And then let's come to this. And so now I'm selecting all of this as my range. I'm doing data analysis of variance, one factor. Why is this thing not showing? For God's sake. Yeah, single factor analysis of variance. So for the person that said, how did I select my data? If you come to the first one, control, you can press Control Shift, then the right arrow, then Control Shift again, the down arrow. So it will select all your range for you. Then I'm grouping by column. I've selected my this. I want to do a new worksheet. New worksheet. I want to delete this guy. So I'm doing a new worksheet. So that will be easier for every one of us. And then if I click OK. So this is my, still do not present the, still do not present the data the way I want it to be presented. So, but I will explain it nevertheless. So I believe you can still hear me and you can see my screen. Let me just make this bigger a bit. So this is a one-way ANOVA and this is what it looks like. So first, one-way ANOVA will do a summary for you before going ahead to do the analysis of variance. So let me expand this column more. This is minus 11. Okay, so here is group. So instead of calling these groups, I was, I know where the mistake is coming from. Please let me do it again. Yeah, I did not select the name of the column. I selected it now. Ah, I mean, I understand the result. I just want every one of us to get it. And that is why I am going back and forth. Apologies for that. But it's still not picking it. I wanted to pick the name so that, yeah, instead of writing 71, it actually writes mathematics for me. It actually writes mathematics for me. And that is what I have been trying to do. But it is not, doesn't want to do that for me. I want to give it a last try. Okay, that does not matter because it will still not work. So let's just go and explain what we have. So simply this part, this group one is supposed to be mathematics. This one is supposed to be English. This one is supposed to be biology. This one is supposed to be physics. This one is supposed to be chemistry. And this one is supposed to be average. Yes. Somebody saying, no, it can actually do analysis of variance. It's something, basically, somebody said the data is not suitable for analysis of variance. No, it is actually suitable for it. These are different columns and they have different entries. And then I can do a variation comparison between them. And that is this is the exact kind of data that you can use for analysis of variance. So at least I know that about that. So here we have count of each data. We have the sum of each data. It takes the average of each data, then it does a variance for it. Now, analysis of variance does a comparison of this variance, and then it gives us, oh, is this significant? Is our hypothesis significant or not? So let me just explain this table of analysis of variance to us. Basically, if you are presenting anything, this is what you present for analysis of variance. So it's saying between the groups and within the group. So between the group is saying between mathematics and English, between mathematics and chemistry, between mathematics and biology, between mathematics and average. So sometimes it is just better that you choose only two column. You choose mathematics and maybe average. But you can actually do multiple columns for analysis of variance. But if you want to know that is when we go to two-way ANOVA with replication. We are going to see that when we go to two-way ANOVA with replication because it will actually do the table. It will actually do table for each of those value, mathematics and English, and then it will now do a general analysis of variance for all the table. So here we have sum of square, and the sum of square between the groups is this. Then the sum of square within the group is this. So the reason why this one is actually more is that it is taking each person's name as an entity to analyze. But the reason why this one is less is that it is taking a column as an entity to analyze. So here is the difference. So when I say between group, I'm actually saying between mathematics and physics. But when I say within group, we have 85 students in the class. So it is actually going to compute sum of square for all the 85 students. But when it is between group, it will only compute sum of square for all the 5 groups. So we also have degree of freedom. There's something we call degree of freedom. And this degree of freedom is usually n minus 1. So it's just saying that, when we have let's say a container, okay, let me use this, what can I use as an example? Something that is sealed, but by the time you remove one from it, those things become free. You can shake them and they will shake. I'm looking at maybe using all these sweets. There are some sweets whereby when you buy them, they are tightly sealed together because maybe they have 10 and the container can only fill 10 perfectly. And then when you shake it, it does not shake because it is only 10 that is there. and there's no space. But by the time you remove one, you are able to shake it, because that one that you remove have given the remaining 9 that is inside a degree of freedom. And that is the same logic that is here, degree of freedom by which each data point can move. They can actually move around and we can measure their variance. That is why we have degree of freedom. So we have degree of freedom to be n minus 1. So here I've selected 5 subjects and average. So for the group, we have 6 minus 1, it will give us 5. And also here we have 85 students in 5 places. So this one is actually going to be minus 5 because we have them in 5 places. So that is how the degree of freedom is being calculated. Then we also have mean squared. So mean squared is a common metric. We use it even when we do linear regression, when we do classical modeling like mean square error and the like. So mean squared is actually one of the values that is important for us to know, yes. And it is always calculated by doing sum of square divided by degree of freedom. Sum of square divided by degree of freedom is going to give us this mean squared. So sum of square divided by degree of freedom. So you can actually check it and see if that is correct. So this is like a little bit of statistics and I'm a little bit rusty when it comes to that area. So but let's check mean squared. So if we do equal to, so mean squared is not a static metric. It depends on the analysis you are doing. It depends on the analysis you are doing, but most of the time it's actually sum of square. Most of the time, sum of square divided by something. So equal to this value divided by this value. So if you press enter, you can see it is sum of square divided by degree of freedom, and that is correct. So we also have the F value. F value, F value is a ratio between, okay, this P value is what is important. It is the one that I tell you whether you are going to accept your degree of freedom or whether you are going to accept your hypothesis if there is actually a significant variance between them or if there is no significant variance between them. So F value is a measure of variation between these two guys. Yes, because whenever you are doing analysis of variance, there's reason why we are doing between the group and within the group. So if we do the ratio of this and this, yeah, I think this divided by this, or yeah, this divided by this, you are going to get this. So this one is just a ratio of between the group and within the group, this divided by this. Then p-value is always, it is acceptable when it is less than 0.05. Remember that we set I said less than 0.05, 0.5. We set our level of confidence to be 0.05. So it is whatever you set your level of confidence to be. Sometimes you set your level of confidence to be 0.5 based on your analysis. And then sometimes you set your level of confidence to be 0.05. So your p-value is actually acceptable if it is not greater than 0.05. And from this guy now, you see, it is exponential raised to power minus 11, meaning that this is far from 0. So it is very, very trivial, meaning that we can actually reject this null hypothesis. So this is a little bit statistics, because by the time I'm saying reject null hypothesis, some people might think that we are rejecting all the analysis. Is actually a negative word canceling a negative word, meaning that accept your analysis. So reject is negative, null is negative, but we have a hypothesis. So if you say reject null hypothesis, meaning that accept your hypothesis. But if you say accept null hypothesis, that means that reject your hypothesis. But it's a statistical way of speaking. When you say reject null hypothesis, it means that whatever you have hypothesized is correct. If you say accept null hypothesis, whatever you have hypothesized as not correct. So how do you know if it is correct or is not correct? If it is less than your level of confidence, it is, I mean, your significance level, yeah, it's level of confidence too, it is acceptable. But if it is greater than it, it is not acceptable. Then we have the critical score. Yeah, we have the critical score, or you can also call it critical value. And it is always from F critical. We have the critical score and we have or the critical value. So here is it. This one is just saying total of sum of square and total of degree of freedom, adding this and this together. So let us look at two-way ANOVA and let us see how it is different from a single-way ANOVA, two-way ANOVA, and how it is different from a single-way ANOVA. And that is what we are going to be able to take for statistics in using Excel. So let's come to our data. Let's come to our data. Let's click data analysis. Let's click two-way ANOVA with replication. I want to show you how it does it in such a way that we are able to understand it. So click OK. This time around, okay, let me select average too. So there is a particular rule with two-way ANOVA, is that this row per sample is actually a breakdown of how many entry you want per sample, because it's going to be doing it in two ways. It will do it sample by sample. It's just for better accuracy, and that's why it's called two-way ANOVA. So instead of doing all the analysis at once, it's going to calm down and do it sample by sample. So if I have 85 students, I can do them in 5 samples. I can say, okay, 5 students per sample. It's just like breaking a task down into batches. Let's say I want to do in a class of 20, I'm doing 5 today, I'm doing 5 tomorrow, I'm doing 5 next tomorrow. Then at the end of the day, I take all of them together and I do the analysis of the results that I have from each group. And that is why we call it two-way ANOVA. And this is how it works. So it means that I have to divide all these my students into different samples, or let me say, yes, into sample or into cluster. So I can divide them into 5 cluster. So if I divide it 5 students into 5 clusters, I'm going to have something like, say, 85 divided by 5, 8 divided by 80 divided by 5, that's 5, 30, 16, 17. So if I have 17 samples, that's quite much. Then my level of confidence or significant level is also 0.05. That's also acceptable. Then I can do a new sheet if I click OK. So here is what it does. So we are going to see that it's taking, it has broken this down into 1, 2, 3, 4, 5, right? 1, 2, 3, 4, and then we have 5. So per each sample, there is how many students? There's 17. So there are 17 students in each cluster, and then it's doing it 5 times for us to cover the total of 85. And then after that, it's come and do like the sum of all the 85, which is the sum of all the 5 groups, then before doing our table of ANOVA. So this is the most important table, like I always say, for analysis of variance. All these ones are background work, and if they are scoring you, they just probably score you small, they just give you a small score. But it breaks it down into sample before doing the whole analysis of variance. And you can see it does the same thing. First, it counts, after it sum, average, and variance. Then the variance, it then do a comparison of the variance. It does a comparison of the variance, and then we still have our sum of square, degree of freedom, mean square, F value, P value. You can see P value 0.1, This one is very less than 0. This one is 0.8. Then we have the F critical score. So if a statistician, somebody that actually have good understanding of statistics, if they're able to see this table, they know whether to accept null hypothesis or to reject null hypothesis. So that there are more analysis that can be done. Then we are, yeah, thank you. Then we are able to know if we are to take the null hypothesis or to reject the null hypothesis. But yeah, so I said we want to look at some more. So we can actually look at correlation and take that as our final. So if you want to look at correlation, so if you click OK, it will tell you to input your where is it? Yeah, so input your range. So my range I'm coming to look up. I want to actually do this. I'll come up here. So I want to do this and this. So I'm doing mathematics and average. So I want to do like a correlation between mathematics and average. So I've grouped by column and then a new sheet actually. A contiguous cell. I don't know. Come on, let me just do something. I have this value. I'm trying to do a correlation between English and mathematics. So here is my correlation value, but I don't like the way it's presenting it to me. There's a better way I can actually do that, and it will present it better. Somebody's saying they can't hear me. Yes, because you have not enabled the adding. Praise, you are supposed to. We did a step. We actually did adding for. We did the adding plugin for Excel before you'll be able to access this data analysis tool. So, I'm trying to figure out because I'm supposed to just get a single value. If I do correlation, I'm supposed to get a single value. Let me do this. Okay, still the same thing actually. Same thing. But basically what it does, the correlation between, where is it? So basically the correlation between English and mathematics is 0.49. The correlation between mathematics and mathematics is 1. The correlation between English and English is 1. I believe we all understand this. When we do this and this is English here and this is mathematics here. So the correlation between English and mathematics English and English is 1 because they are the same entries, but the correlation between English and mathematics is 0.49, which is positive, so which is actually still good. So let us just look at the correlation between, I'm trying to do mathematics and average, and it is not allowing me to do that. So I'll just do correlation for all the data. Yeah, I'll just do correlation for all the data so that I have like correlation matrix. I was trying to avoid that matrix before. Okay, yeah, this particular one will give me matrix. I'll show you the one I was thinking I would get before. I think there's no time again, but I'll still show you. So this, I specify my range first row as data label, a new sheet. It will print for me. Um, I don't like what this thing is doing. This is not what I'm expecting. I'm expecting a matrix. I'm expecting a matrix. I'm actually expecting a matrix. Um, Sorry, I'm coming. Okay. So basically, you can try it on your own because of time. Actually expecting a correlation matrix, but it's not giving me a correlation matrix. I'm expecting something like this. So I'm actually expecting something like, let me just look for it. Yeah, I'm expecting something like this, but with more subjects and more rows, so that I have like a matrix. So I have like a matrix. So the other way you can do a correlation is simply by, let's look for that lookup, is simply by doing equal to correlation, and this is the one that will give you a single value. Equals to correlation, then I can specify my first range between mathematics, and then if I put comma between mathematics and average. So this is the one I was thinking, I was actually trying to do before. So this is giving me a correlation of 0.7 mathematics and average. So I can see that, yes, there's a significant correlation between mathematics and their average, 0.7079, and that is correct. So guys, although I have in store for us to do a dashboard today, but we'll not be able to do that because of time. But I want to believe that you have been able to get the core the core proposed knowledge for this class, which is statistics with Microsoft Excel. And you can actually explore, because the aim of this is to have like an understanding of what you can do and how you can do it. You can actually explore more on your own, try the Fourier analysis, try the t-test, try the correlation, try the ANOVA analysis of variance, look at the results, try to understand it. Yes, I can see what somebody actually got using using the correlation. And yes, this is more like what I'm trying to get. This is a correlation matrix. And then you can see for each subject against each subject, you see the correlation. You can see correlation between average and mathematics, average and English, and everything is actually above 1, meaning that there is not one that is very bad. So thank you very much, guys. And we'll be stopping here now. And if there's any question, you can drop it in the chat to be able to pick it. And it's awesome being your facilitator. And we are going to stop here. All right. Thank you very much. Over to the facilitators.
Wow. Wow, 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 wow. Awesome delivery. Please confirm you can hear me. Hello. Oh, please confirm you can hear me. Thank you so much, Team. Thank you so much, Go Flora. I told you, you are going to be wild by the end of the session, and you will agree with me that this is another superb delivery. Thank you so much, Mr. Olamide Shobamu, for this wonderful session. Yes, 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 yes. It's been another 2 hours of learning. It's been another 2 hours of learning. Thank you so much. Thank you so much for doing this for us. And yes, so I can see some questions on the chat. Oh, my matrix is not working. Oh, my DF is not doing this. How did you pick two of this? So this session is we're already streaming to YouTube, which means that once you are done here, by the time we're in this session, it's going to be available for public consumption on our YouTube page. So you can just quickly move on to the YouTube once we are done with this session here. This session is recorded and it's going to be available immediately after we end the Zoom call here on our YouTube channel. Yeah, everyone, it's been a whole week of learning, and it is very important that even after today, we go back to all these recordings and we digest everything one after the other again. Yeah, we agree. You will agree with me that it's been a whole lot to take in at a time. This is like 2 hours, 2 hours, 2 hours every day, or even 3 hours. Yes, so it's been a lot. So after today, I will encourage us all to go back again to day one, check through the video, go back to day two, check through the video, go back to day three, check through the video up till today, which is the day five. That is how you'll be able to actually catch up with all these learnings. And even after that, there's a need for you to practice because these classes are actually hands-on. Yeah, they're fully practical. So make sure to get one or two people, teach them again with what you're learning. This is the best way to seal whatever you've learned. Yeah, so just few announcements again before we end the session. So we know that some of you, I mean, it's very good when you learn something, you tell people. I mean, that's a way to actually show that who you are learning. So you may want to share your learning experience with your family and friends. We've dropped links in the chat. I mean, tags and organizations to tag because this program is actually sponsored by Microsoft while DSN is the one championing the delivery. Yes, so when you are making your learning, when you are sharing your learning experience on social media, do well to tag all the organizations or the names and use the hashtag that has been provided in the chat. And also, like I said, the attendance form is opened. So we've been taking attendance since day one. Today is the day five, so make sure you fill your attendance too. And this is not the end. I'm repeating it again. This is not the end. Next week, Monday, from July 8th to July 12th, we're going to be continuing with the data analytics with Power BI. Like I said, this training is actually made in such a way that the learners are graduated. Now we've learned the basics of Excel. By next week, we are going to be making use of this basic knowledge for Power BI so that we can now start building advanced dashboard, making our report, understanding how to use tags, understanding how to perform what we call queries. Yes, so next week is going to be for data analytics, and we have three modes of delivery. We have the physical, which means that we are going to be having some physical hosting centers across the country. We are going to be publishing the list of the approved hosting centers today so that by tomorrow everybody can start checking. And we're going to also be doing a detailed mail to everybody so you can see the list of the available hosting center that will be hosting the data analytics with Power BI physically. And we're also going to be having the virtual call just like this for the whole 5 days. And we're going to be having the last one, which is the self-paced. So the self-paced is for those that cannot attend physically and cannot join online like this because we know people are actually busy and in the community we have various segments of learners. So the self-paced is more for people who cannot do the virtual learning and also attend physically. So we have the self-paced for you to catch up at your own convenience. Thank you so much, everyone. Thank you so much for joining us today. We're excited to have everyone. So, like I said, the learning continues, and you can also drop your conversations on the Telegram chat. So, my colleague will be dropping the link to the Telegram chat. So that's where we have the whole of DSN community uh, where we engage part time. So, if there's anything you need, you can drop your questions can drop your inquiries, can drop your inquiries on the Telegram group. Thank you so much, everyone. Do enjoy the rest of your day and have a great weekend. Bye bye.